All right, so today's notes are again on modeling with a quadratic. Our content objective is this time to write an equation of a quadratic given 3 coordinates, so slightly different from last time. You'll see why it's slightly different from our previous examples. And our language objective is to explain the process for writing the equation of a quadratic given 3 points. So before I delve into the specific example for today, we're only going to go through one longer example. But before I delve in, I just want to point out that our big plan for today when we're solving is when we're given 3 points, we set up a system of equations and solve for A, B, and C. So if you remember, Unit 3, we did systems of equations. I've told you before, things we learn always come back up. They're never going away. So we will be solving systems today. Again, but in order to do that, we're going to have to set that up using our quadratic forms first. So it's going to start out like our problems from yesterday did. So our example for today says a man throws a ball off a building and records the height of the ball at different times as shown in the table. So here's the table. Again, X independent variable will be time, Y dependent variable will be height. So we're going to start by identifying your key features. I did this over here this time so that I didn't have to crowd it over here. I don't know my x-intercepts because I don't have y equals 0 at any of these points, so I don't know my x-intercepts. My vertex, I don't know. One of these could be the vertex, but there's no proof that any of these were the maximum height that the ball reached, so I don't know my vertex at this point. I do know my y-intercept because I have a point where x is 0, or have the point where x is 0, so I know my y-intercept is 0.46, so I do know my c value. And I do know several other points. So I didn't write them all here because these are all the other 3 points in my table. So I know 3 other coordinates besides my y-intercept, which will help me solve this problem. So I'm going to choose the most helpful form in the situation. Since I don't know the vertex and I don't know the x-intercepts, I'm going to go to the other option, standard form. So since I don't have the key points for those 2 options, I'm going to go to standard form, and I'm going to start by substituting the points to set up a system. So before I do that, real quick, I know because of my y-intercept in standard form, c will be 46. So I'm going to use that when I'm writing my equations or plugging them into standard form. So again, standard form is y equals ax squared plus bx plus c. And I already know c is going to be 46. So then I'm just going to choose another point to set up my system. So I'm going to set up this one here. So I'm going to say 63 equals a times 1 squared plus b times 1 plus, I know c is 46, so that's going to go there. So then I'm going to simplify. So I get 63 equals 1 squared is 1 times a is still a, b squared, or b times 1 is just b plus 46. And since I am going to set this up so I can have my constants on one side, so I'm going to subtract 46 from both sides, and I get that 17 equals a plus b. So there's my first equation when I plugged in one of my coordinate points. So now I'm going to do another one. So I'm going to do the little spiral to set up this one, so you know where I'm getting this information. But I'm going to say 48 this time equals a times 2 squared plus b times 2 plus, again, c we know is 46, so I can continually use that. So then I simplify this version and I get 48 equals 4a plus 2b plus 46. And I'm going to again subtract my 46, so I get my constants all on one side. So I get 2 equals 4a plus 2b. So now I hope you guys all see that I have 2 equations with 2 variables. So 2 equations, 2 variables. So now I have a normal system of equations I can use to solve this problem. So then step 4 will be to solve the system. So because I don't have a lot of room here, I'm going to flip the page for this. I'll copy these equations, these 2 equations over to solve this. But I'm going to flip the page to finish solving this system. So I have plenty of room. So again, I have 17 equals a plus b, and I have 2 equals 4a plus 2b. So you could use substitution or elimination, whichever one you prefer. I'm going to use substitution. So I'm going to subtract b from both sides, or a from both sides. So I get b equals 17 minus a. So all I did was subtract a from both sides. I get b equals 17 minus a, and now I can substitute that into b. So I'm using substitution here. So I get 2 equals 4a plus 2 times 17 minus a. And now I can solve this out. I distribute, I get 2 equals 4a plus 34 minus 2a. Now I subtract 34 from both sides. I guess I'll show all these steps since I have room now. Minus 34. I get negative 32 equals 4 minus 2 is going to be 2a. Divide by 2, negative 16 is equal to a. So now I have a is negative 16. I can plug it back in here to solve for b. So I get b is equal to 17 minus negative 16, which means b is equal to 33, because this minus minus becomes plus, so b is equal to 33. So now I have a, b. I already knew that c was equal to 46 from our first initial problems. So now I can, my last step, step 5, I can write my full equation. I write the equation in standard form. So y equals negative 16 x squared. So keep in mind you're plugging in for a, b, and c. So now you have x squared and x coming back. So negative 16x squared plus 33x plus 46. And that is standard form of that quadratic. All right, so that's it for today's lesson. We will practice these some more in class, but make sure you write down any questions, comments, or concerns you have so we can go over them together.